let's take a quick look at weak acids. So weak acids are acids that are weak electrolytes in water. So what that means is that they break apart partially to form our conjugate base and conjugate acid pair. So we have our weak acid here. It's combining with water, and notice that we have this double arrow, so it goes back and forth. What that means is that a weak acid is at equilibrium, so they don't go to completion. They don't completely break apart in water. So in water, this acid, so this is acetic acid, is going to exist where you've got some of the CH3COOH, so the full acetic acid. You're going to have some of the acetate ion, and you're going to have some of the hydronium ion. And all three of these things are going to be in the solution at the same time. We have some extra terminology that we look at with weak acids. We can actually look at this with strong acids as well. So we have our weak acid, and once we take the hydrogen away from it, this becomes our conjugate base. We can also look at whatever it's reacting with here is acting as a base. So this is our base here, and this is the conjugate acid. So essentially, when we're talking about acids and their conjugate base, or base and their conjugate acid, is we have our acid. So I'm going to have a general acid. It's got H, and there's some sort of anion here. And it's going to combine with water to form, so that H plus is going to move over to the water. The anion is going to end up by itself. So we're going to end up with our anion, so whatever that may be, aqueous because it's now dissolved in water, plus H3O plus. So we're taking away one H plus ion from the compound, moving it to the water to make our conjugate base. So the conjugate base is essentially what's left over when we take the hydrogen away from our acid, and we have our conjugate acid. It's where the conjugate acid is where that hydrogen goes to. So this is going to be, you're going to want to be able to figure out what the conjugate base or what the conjugate acid would be for any compound. Now if we look at the base here, so water here is acting as a base, and we can tell that because it's gaining a hydrogen ion. So we're adding the hydrogen ion to it. So we're going to take our H2O and we're going to add an H plus to it. So there's now 3 hydrogens and a total positive charge. Okay. So I'd like you to practice. Here are some acids, and I'd like you to try and figure out what their conjugate base would be. So I just go ahead and pause the video, and then I'll show you the answers in just a moment. So the answers for what these conjugate bases would be: hydrochloric acid, I'm going to take the H plus away, and I'll be left with Cl minus. So do be careful about the charges on these. Acetic acid, I take away the H plus, I'm left with the acetate ion. NH4 plus, I already have a positive here, so if I take that positive away, my conjugate base is going to just be NH3. So I'm going to take the H away, I'm going to take that positive away. H2O, I take away an H plus, and that's going to give me my hydroxide ion. So initially you might have thought that this would be HO minus, but we have an ion, we already write that as OH minus. So just be careful if you do see this form of your anion. This is going to come up really often, so I wanted to make sure you see this here, is that, sometimes if you take that H plus away, you end up with an H, you have an O, and no overall negative charge, and we write that as OH minus. So you do want to make sure you can recognize that when you see it. H2SO4, I want to take away just one of these hydrogens, So I'm going to be left with HSO4 minus. Now you do also want to practice the opposite. So these are some bases, and you want to come up with their conjugate acids. So give you a moment to pause the video, and then you can forward to see where check yourself on the conjugate acids. Remember, you're going to add H plus to each of these. So these are the answers. I'm going to add H plus to Br minus. It's going to be HBr because the positive is going to cancel out that negative. Same thing with my fluoride ion. HF is the conjugate acid. NH3, I add my H plus, gets my 8H4 plus. OH minus, add that H plus, that gets me water. So you might have thought that this, you add your H plus and you get HOH. Well, we have something that has two H's and one O. We write that as H2O. So just be aware of that as well. And our last one, we add our H plus to SO4 2 minus. And that's going to give us HSO4 minus. For the conjugate acids and bases, make sure that you can identify your conjugate acid base pairs in a balanced equation. So do make sure and practice that.